All right, so this is problem number 22 for the bonus problems for exam number 2. For this problem, we're asked to determine, so basically the question says, a copper nail and iron nail of the same mass are initially at the same room temperature. Both are put into a vessel containing boiling water. Which one do you expect to reach 100 degrees Celsius first, and why? So this problem is basically determining, okay, which one's going to heat up faster? So we need to know a couple things. First of all, we know the heat formula, Q equals mc delta T. We can actually use that for this problem just to kind of get an idea to explain the reasoning as to why which of the two is going to heat up quicker. So we're not given a mass, like an actual mass. We just know that they're the same. So let me just assume that their masses equal 1 gram. And it says it's same room temperature, but what I'm going to do here is I'm just going to let delta T, in this case, equal 100 degrees Celsius, since it's a nice, nice even number. So how do I determine which of these is going to heat up faster? Well, this is going to come into the C value, the specific heat. So you can refer to tables on, through the folio or look online to determine which of these two elements are going to have a higher specific heat. So I took a look. First and foremost, iron is going to have a specific heat of, let me see here, 0.45 joules divided by grams times degrees Celsius. And copper, what I found, has a value of 0.39 joules divided by grams times degrees Celsius. So copper is going to have a smaller specific heat. Now, when we calculate these numbers, we're going to, for the Q value for the heat, whatever's going to have the higher energy used is going to be the one that requires, which is going to be the one that's going to take longer to heat up because, of course, using more energy. So if I apply this calculation for both of these terms, or both of these nails, let's see which one of these is going to be which one of these is going to take longer to heat up. So one thing to keep in mind, now this 0.45, from what I was looking at online, there was a couple that said like 0.448, 0.444, and then with copper it was like 0.385, 0.387. So I just kind of rounded off a little bit because they're pretty relatively close to the values that I saw. So now let's check for Q of iron. So the heat for iron, the energy required to heat up an iron nail. So we said that the mass was going to be 1 gram multiplied by its specific heat, so 0.45 joules divided by grams degrees Celsius times the 100 degrees Celsius change in temperature, we assume, because we're going from, let's just say, 0 up to 100 degrees. So I know that my degrees Celsius are going to cancel, my grams are going to cancel, and I've got 1 times 0.45 times 100. That's basically 45% of 100, so that's going to become 45 joules. So 45 joules of energy is required to heat up iron at 100 degrees an additional 100 degrees Celsius when it weighs 1 gram. Now let's check copper. So the heat for copper is going to equal 1 gram times 0.39 joules divided by grams degrees Celsius times 100 degrees Celsius, because again, the temperature and the mass are the same for these two. The only thing that's different is their heating, specific heat. And again, my units are going to go away except for the joules, and I've got 100 times 0.39 times 1. That's going to give me 39 joules of energy required to heat up a copper element all the way up to 100 degrees Celsius if it's 1 gram. So looking at these numbers, which one is higher? Well, iron is higher. So that means that more work is going to be required to, or let me reiterate, more heat is going to be required to get that iron element an additional 100 degrees Celsius compared to the copper that's only going to require 39 joules of heat. So we can say that the copper is actually going to heat up faster. And again, that is because its value, if we looked at these two values here, it had a smaller specific heat. The higher the specific heat, the longer it's going to take for something to heat up. If you think about water, water's got a specific heat of 4.184 joules divided by grams times degrees Celsius. So we know that water is going to take quite a while to get, if we have 1 gram of water, it's going to take a little while to heat up at 100 degrees Celsius. So For this video and for this problem, the solution that we're looking for is copper. Copper is going to be the one that reaches first, specifically because it's got a smaller specific heat.